Hello everyone, welcome back to the Theory of Computation course, and in this video I'm going to explain about DFA model in Theory of Computation. So basically in Theory of Computation we have four models called DFA, NFA and NFA with epsilon transition, and then we have regular expressions. So these are the four basic models which we are going to learn, and in today's video I'm going to explain about DFA, which is Deterministic Finite Automata in TOC. So let's try to understand it first. Deterministic Finite Automata. So let's try to understand what actually happens. So a mathematical model, let's say this is a mathematical model, and this mathematical model will receive some input, and based on that input, before there is a language defined. Suppose if I want a string that must consist of only strings which end with 1, they should end with 1. Like this can be thing 101, 001. So these are all part of the language. There can be many other symbols as well which end with 1. But we create a mathematical model which receives some input strings, and this mathematical model will check whether it is following the rule or not. Like suppose now this is my mathematical model, and this mathematical model now receives a string called 102. Let's say this receives a string called 102. Do you think our mathematical model accepts it? No, it doesn't. It rejects it. Why? Because the string is not ending with 1. But if the same mathematical model receives an input like 101, do you think it will accept? Of course it will, because the string is ending with 1, and that's what we have developed a mathematical model for. We want strings which end with 1, right? So now to develop such kind of mathematical model, the first model which we are going to learn is Deterministic Finite Automata, that is DFA. So I hope you got the basic understanding of what DFA does. So DFA is a mathematical model which receives some input symbols, and these input symbols, like whatever I said, 101, suppose let's take for example, are taken one by one. Like first 1 is processed, then 0, then 1. If the input is 1001, then first 1, after 0, 0 and 1. In this way, one by one, each symbol is processed in the DFA, and there will be some changes in the states of the model, like transitions, and in the end we say whether the string is accepted or rejected. So that's what we are going to do in this DFA model. So before creating a DFA model, we specify the rule. Like I want a DFA model, let's say, which accepts a string which ends with 2 zeros in the end. So I can create a model for that as well. So basically we create a mathematical model and we check whether that model is solving that problem or not by giving some input symbols, and the input symbols will be processed one by one, and based on that inputs, inside the mathematical model there will be a transition in the states, and based on those transitions we will decide whether that string can be accepted or not. So that is basically what a DFA model is. So now let's try to understand DFA even more clearly. So in the previous video I explained something called states, right? So according to DFA, suppose this is my one state Q0, and this is Q1, and this is Q2. Suppose there are three states. So my first state is represented like this because this symbol says that this is the starting state. Like my machine takes input from this state. Like this will be the state which is the first one to receive the input. So basically what happens is whenever a state receives an input, there will be a transition. What does transition mean? Like it moves to another state. Like for example, if I say when Q0 receives 1 as input symbol, it should move to Q1. So what does this mean? How should I represent this in the DFA model? So for the arrow symbol, I am saying that this is the starting state. But when I say Q0 when receives 1, it should move to Q1. This is represented like this. So when Q0 receives 1 as an input, the transition should be to Q0. And for even more clarification, when I say Q0 when receives 2 as an input, it should move to Q0 when receives 0 as an input, it should move to Q2. Suppose this is my condition. If I say, then how would I represent this in the mathematical model? I would say like this. When Q0 receives 0 as an input, it should move to Q2. So this is how it is represented in the mathematical model. And what DFA says is every state, like if it's Q0, if it's Q1 or Q2, should definitely have input paths of all the symbols mentioned in the alphabet. Like suppose if my alphabet is 0, 1, then all the strings which are going to be given as an input to the model will consist of the combination of this only two symbols, right? As I explained in the previous video. So strings can be only formed as the combination of these two symbols, right? Now Q0 should be defined on both 0 and 1. Like what must be the transition from Q0 when it receives 0 as well as 1. So both should be defined. Suppose in this case, in this diagram, you can see now Q1 has not been defined on any input symbol. Like Q1 doesn't have any path on 0 and 1, right? So I must give a path from Q1 on input symbol 0 as well as 1. Like suppose if I give when Q1 receives 0 as an input symbol, it should stay there. Now if I leave the model like this would be incomplete because I did not define Q1 on the state 1, on the input symbol 1. So I have to mention the input path on 1 as well. So if I say Q1 when receives 1 as an input, it should move to Q2. So this is how I represent it. And now I have completed for Q0 because it has a 0 path as well as it has a 1 path, and Q1 also has 0 and 1 both. But now Q2 doesn't have two paths. It doesn't have path for 0, it doesn't have path for 1, so I have to define for both. So for this example, I am treating both 0 and 1 should stay here. And there is one more thing which we need to keep in mind, that is called as a final state. So what is this final state is? A final state is represented with a double circle. Suppose let us take this Q2 as the final state. So because this is represented with a double circle. Now, okay, I have explained what internally happens, like how the transition takes place, how the input symbols are received by the states, and how they move between the states. I have explained this. And one more thing to keep in mind is there can be only one starting state. This Q0, there can be only one starting state, and there can be many final states, but there can be only one starting state, and there can be any number of states but not infinite. That's why it is called as finite automata, because there can be only finite number of states. And why it is called deterministic? Because every state should be defined on every input symbol, and each input symbol can only have one path. Like, what that means if q0 receives 0, then it will only have one path. Like, either it will go to q1 or q2 or q0. In this case, I have said when q0 receives 0, it will move to q2, right? But if I try to say when q0 receives 0, it will move to q1 as well, then this would be wrong, because one state has two input paths on the same symbol, which is not accepted in DFA. So DFA is called deterministic. Why? Because every input symbol has only one path on every state. So every state must be defined on every input symbol, and the input path must be only to one state. There cannot be multiple input paths. So I hope you got why it is called deterministic and why it is called finite, because there can be only finite number of states. So I hope you got it. Now, how a DFA model accepts or rejects. We have seen that there are some transitions between the states. Okay, that's fine. If there is a string called 101, then one by one the strings are given to the model, and based on the inputs there will be some transitions, and that's fine. But how can you say did the DFA model accept the string or not? That can be explained by the states itself. I have said something called final state, right? And this final state is represented by like this, double circle. So whenever, actually in the state diagram, if I have this q0, q1 and q2 as the final state, if I say, now if I receive, now I'll start receiving the input symbol. Suppose my input symbol is 101. My mathematical model will receive input one by one, like it starts with 1, then it moves with 0, and then it ends with 1. At the end of the string, what should happen is, if a string ends, then my mathematical model should end at final state. Then we can say the string is accepted. I mean, if there is a string, then at every input, like if it is a 101, you take first 1 as an input, you move to q0, and you take 0 as an input, and you take let's say you have one more state called q3, and this is normal state, don't think it as a final state, and there is a one more state called q3. Now it will receive one more symbol called 1. So after the completion of the string, the model has ended at the state called q3, which is the final state. So by this we can say, so when a string ends and after the completion of all the transitions, if we end at the final state, then we say the string is accepted. Otherwise, after the completion of the string and after the completion of the respective transition of the states, if we still end up at any other state other than final state, then we say the string is rejected. So the main thing we need to keep in mind is we have to design a mathematical model in such a way that it takes the input symbols, it goes under the transitions, and at last when the end of the string, when it occurs, when it reaches at the end of the string, for the last input symbol, it should end at the final state. So that's what we need to keep in mind. So when it ends at the final state, we say our model is correct and it is accepting the string. But when it doesn't end at the final state and it ends at any other state other than the final state, then we say the string is rejected and our mathematical model doesn't accept is not correct. So basically we have to design in that way. So we have to design in that way so that our model takes some input symbols, goes under transitions to different states, and at the end of the string, receiving the last input symbol, the transition goes to the final state. And if the transition goes to the final state, then we say that our model is accepting the string. But if it doesn't, then yeah, we didn't do well. So I hope you got it, how a DFA model is accepting and rejecting the strings. So now I will give an example. With that, it will become more clear. So let's take a problem which says we will create a DFA model and which accepts zeros and ones of strings ending with two zeros. So for this model, for this question, we are going to create a mathematical model which accepts strings ending with two zeros. Like for example, if it is 1100, it should accept. If it is 100100, it should accept. But do you think this should be accepted? Yes, of course it has two zeros, but the string is not ending with two zeros, so this should be rejected. And if I say 11100, do you think it should be accepted? Yes, of course, because it has two zeros, so the string is ending with two zeros. So in this way, we are going to create a model, a mathematical model, which accepts strings ending with two zeros. So how are we going to do that? Let's create a DFA model. So our DFA model, to create a DFA model, first thing we need to understand is we need to take the base condition. So what is our base condition actually in this case? We need a string ending with two zeros. So do you think this has to be accepted, the only a string with two zeros itself? Do you think it should be accepted? Of course, because this is the base condition. We need string which ends with two zeros. So take the lowest condition possible, and that is this. We need strings ending with two zeros. So let's take this base condition, and with this base condition, we are going to develop a mathematical model, that is our DFA model. So let's try to build that. Now, so they are basically two zeros, right? So I am going to write 0 and 0. So now this will be my starting state, and this will be my Q1 state, and this is my final state. So this is how we are going to make a basic model on the base condition. Like I have two zeros, so I have taken three states, which says that Q0 is the starting state, Q2 is the final state, and Q0 when receives 0 as an input, it will move to Q1, and Q1 when receives 0 as an input, it will move to Q2, right? So what I have said, we have to create a model which should accept strings ending with two zeros. So how can I say a string is accepted? When after the completion of the total string, if we are transitioning the states, and if we end up at the final state, then we say that we have accepted the string. So here we have two zeros. So on the first zero from Q0, as Q0 is the starting state, so it will be the first one to receive an input. So Q0 receives a 0 and it will move to Q1, right? Now I have one more 0, and this 0 is received by q1 because previously when q0 received a 0 we ended up at q1, so now q1 should take the input. So when q1 will receive the second 0, we are saying that when q1 receives a 0 we will move to q2. So now we have ended at final state, right? This is the final state, and our string is also completed. So we say this string can be accepted. So whenever we get two zeros as input, this is accepted. But do you think 100 can be accepted? Why it cannot be accepted? Because q0, the first symbol it receives is 1, and there is no input symbol path defined on q0 for 1. So this mathematical model is not complete. So we need to complete it. So what I said as per DFA, every every state in DFA model should be defined on all the input symbols. Like in this case, which accepts zeros and ones. So the alphabet is 0 and 1. So all the input symbol paths must be defined on all the states, and each input symbol should have only one input symbol path. Like now q0 has 0 to q1, so q0 on 0 should not be transitioned to any other state because it already is defined to q1. So the only thing remaining is q0 on 1. So we need to define q0 on 1. So now we need to decide q0 on 1, right? So I need to define q0 on 1 in such a way that whenever I do transitions, I should end up at the final state. So first thing you need to keep in mind is, now what you need to define? You need to define q0 on 1. So now you stand up at here, q0 on 1. So q0 on 1 has to be defined. So if q0 has to be defined on 1, and my requirement is my string should end up with two zeros. So what I will do, so okay, q0, which will take the first input, but after the transitions, I should take two zeros such that after receiving these two zeros, I will make transition in such a way that I end up at the final state, right? For more clarity, if I say, now I have to define q0 on 1. So now when q0 receives 1 as the input symbol, I have to make transition in such a way that when the other states receives two zeros, the transition should be in such a way that it should end up at the final state. So I am saying that when q0 receives 1 and stays here itself, then 1 is completed, and for the 0 symbol it will move to q1 state, and for the other 0 it will end up at the q2 state, right? So this is how we are going to define the path for an input symbol. So for now, for q0, 0 and 1 both are defined. Now let us try to define 1 for q1 because 0 is already defined. So for now what you need to do, you need to stand up at q1. But in order to reach q1, what must be the first input symbol to reach q1? Because when q0 receives, because q0 is the first state which is going to receive the input, and from q0 we need to reach q1, right? So from q0 to reach q1, what must be the input symbol first? It should be 0, because when q0 receives 0, then we stand at q1, right? Now I need q1 on 1. And what is my condition to accept the strings? My string should end with two zeros. So I will keep two zeros here. So the first thing you need to remember is, if at all we want to define an input symbol on a state, first we need to stand on that symbol. In order to stand on that symbol, we need to take some inputs first. Why? Because q1 in this case is not the first state. The first state is actually q0. So in order to stand it there, what is the path actually? When q0 receives 0, then it will move to q1. So the first example string I have taken is 0. Now on what part I need to define q1? Now after receiving the 0, I am standing at q1. Now on what input symbol I need to define q1? At 1, right? So I will write 1. And I need to define q1 on 1 in such a way that after receiving q1, after q1 receives 1, it should be transitioned to that state such that from that state, if it receives two zeros, then it will end up at the final state. So from now q1, when it receives 1 as an input symbol, it should move to that state from where if I give two zeros as input, it should end up at the final state. Can you see that state in this diagram? If I move to q0, when I take q1 on 1 as an input symbol, then what happens? For the first input symbol q0 on 0, I am coming to q1, and q1 on 1, I am coming to q0. And then q0 on 0 will go to q1, and q1 on 0 will go to q0. So we are ending up at the final states. The string is accepted. So I hope you got how q1 on 1 is defined. Now q0 on 0 and 1 both are defined, and q1 on 0 and 1 both are defined, and the remaining is q2 on 0 and 1 should be defined, right? So in order to define an input path on a symbol, what I said, you need to stand on that input, you need to stand on that state. So in order to stand on that state, how do you do that? You need to again start from q0. So from q0, you need to reach to q2. How you will reach? q0 should take a 0 and it will come to q1, and q1 will take a 0 and it will come to q2. So in that way you will stand at q2, right? So the first example input symbol is two zeros. So with these two zeros, you can say that from q0 you actually reach to q2 state. And now q1 on 0 has to be defined, right? So you take this 0. This is your example problem. By these examples, you need to actually define your state diagram. Okay. So now as part of my example, this is my example, and this is satisfying my condition as well, because this example is ending with two zeros. So q0 on 0 is coming to q1, and q1 on 0 is coming to q2, and q2 on 0 should end in such a state that it should be a final state, because it is actually satisfying the condition. Why? Because it is ending with two zeros. So q2 on 0 should end at the final state. So q2 on 0 should be itself, because it should end at the final state. Now let's define q2 on 1. So for defining q2 on 1, I need to stand on q2. So in order to stand on q2, what I will do? My inputs will be started from q0, right? So I need to start at q0, and now I should reach at q2. So for that, I need to take two zeros. Why? Because q0 and 0 will move to q1, q1 on 0 will move to q2. And at q2, now I have to define on 1, right? Now what is my condition? Does my example fulfill the requirement? No. Why? Because we need strings that will end with two zeros. So I have reached the q2 state and now have to define for 1, but still this example is not fulfilling my requirement of ending up with two zeros. So I add two zeros to fulfill my requirement. Now for this string, I have to make the path so that the q2 on 1 will also be defined. So with the first 0, we will end up at q1 state, because q0 on 0 is q1, and then q1 on 0 will move to q2. We are reaching the final state, but this is not the end of the string. There is still more part of the string. So q2 on 1 should be transitioned in such a way that after q2 on 1 is transitioned, even though we get two zeros, then we should end up at the final state. So in that way, we are going to do the transition. So if I transition to which state do you think it will solve this problem? Because it still requires two zeros to end up at the final state. So what I will do is Q2 on 1, I will move to a state called Q0. Why? Because after the Q2 on 1 will move to the Q0, this input symbol is done. There are two more zeros, and this zero will be received by Q0 and it will move to Q1, and then Q1 will receive one more zero and it will end up at Q2, which is a final state. So the main thing which you need to remember is that every state must be defined on all input symbols, and they must be defined in such a way that in the end, after the completion of the string, the transition must be to the last final state. If the last transition of the string is to the final state, then we say the string is accepted. So we need to develop strings in such a way, we need to develop the mathematical model in such a way that it should end up at the final state. So I hope you got it. It might be confusing for the first problem, but if I explain two more problems, you will definitely get this. First problem will be a bit hard, but yeah, I think this is clear for a bit now. So this is the complete DFA model. Now you give any string to this, like literally anything, you will get the right answer. Like if I give 1 0 0 0, do you think this will be accepted? According to the condition, it must accept this because this is ending with two zeros, right? So the first input symbol, what it is, Q0 on 1. Q0 on 1 will be at Q0 itself, and Q0 on 0, then it will move to Q1, right? Now Q1 on 0 will move to Q2, and Q2 on 0 will stay there. So it's ending up at the final state. So this string is accepted by our model.